Assalamualaikum and hi. In this video, our group will be presenting about the production of chemicals from coal.
As concerns over climate change and air pollution, there is a pressing need to explore alternative pathways that are economically viable and environmentally sustainable, which is conversion of coal into chemicals, offering a promising avenue for diversifying feedstock sources, reducing greenhouse gases emissions, and driving innovation in the chemical industry. It was started early 20th century and up till now. Coal is the complex mixture of organic and inorganic compounds, primarily consisting of carbon, hydrogen, oxygen, nitrogen, sulfur, and trace minerals. The conversion of coal into chemicals typically involves thermochemical processes such as pyrolysis, gasification, and liquefaction. Integrated gasification combined cycle IGCC systems and novel catalysts have been developed to improve the selectivity, yield, and energy efficiency of coal conversion processes, enabling the production of a wide range of chemical products including fuels, fertilizers, polymers, and specialty chemicals. The challenges are process stability and product quality, requiring robust pre-treatment and purification steps. The management of the byproducts and waste, logistical costs must be carefully managed to minimize impact. Emerging technologies such as coal-derived carbon capture and utilization offer opportunities to enhance the sustainability of coal-based chemical production by mitigating greenhouse gas emissions and valorizing carbon dioxide as a feedstock for chemical synthesis.
Now, the history of the production of chemical from coal. On the 19th century, there involved the distillation of coal tar, which yielded a variety of chemicals including benzene, toluene, xylene, and naphthalene. In the early 20th century, the development of the Haber-Bosch process in the early 20th century allowed for the large-scale production of synthetic ammonia from coal-derived hydrogen and atmospheric nitrogen. On the mid-20th century, for the coal gasification, which allowing coal to be converted into synthesis gas or coal syngas, which is a mixture of hydrogen and carbon monoxide. This syngas as a feedstock for producing a wide range of chemicals including methanol, ammonia, and synthetic fuels. Lastly, for the modern era, which is coal-to-chemical technologies, which aiming to convert coal directly into high-value chemicals and fuels. These processes, such as coal liquefaction and coal-to-olefins or CTO, have been developed to produce liquid hydrocarbons and olefins from coal.
For the chemical composition, it varies depending on degree of qualification, geological origin, and depositional environment. It contains carbon, hydrogen, oxygen, nitrogen, and sulfur. The composition of coal influence its suitability for different conversion processes and the products. The conversion process involves pyrolysis, heating coal in the absence of oxygen to high temperatures, gasification, which converts coal into a synthesis gas comprising primarily carbon monoxide and hydrogen gas, and last, liquefaction processes that aim to convert solid coal into liquid hydrocarbons through thermal or catalytic means. Next, separation based on their physical and chemical properties such as distillation, solvent extraction, and membrane separation. Purification by removing impurities and contaminants to meet quality standards and regulatory requirements such as desulfurization, denitrification, and demineralization. And chemical transformations such as hydrogenation, oxidation, and hydrocracking to enhance product yield, selectivity, and performance. So let's move. Catalyst facilitates desired reaction, improving reaction rates, and enhancing product selectivity and quality. Supported metal catalyst comprising metal nanoparticles dispersed on high surface area supports, while hydroprocessing catalysts containing active metals such as cobalt, iron, nickel supported on porous materials. For environmental consideration to minimize its impact, we utilize carbon capture and storage CCS, minimize the energy consumption and resource utilization and waste generation. We implementing emission control technologies such as filters and catalytic converter, and recycling and treating waste streams. Lastly, the economic viability of coal-to-chemical projects depends on various factors, including feedstock availability and quality, capital and operating costs, energy prices, market demand, and regulatory frameworks.
Okay, so next I will be talking a bit about some definition of the process, which is coal gasification and liquefaction are methods to make useful chemicals from coal. Gasification turns coal into a gas mix, mainly hydrogen and carbon monoxide, used to produce synthetic natural gas. Liquefaction therefore changes coal into liquid fuels or chemicals like diesel and jet fuel using high heat, pressure, hydrogen, and catalysts. Some studies show that factors that is affecting liquefaction also affect gasification. Therefore, it was linked together. These techniques, along with coal-to-chemical processes, are important for using coal well, diversifying energy, and making chemicals for industry. Next, some key factors in this process, such as chemical processes, which is various methods are used to turn coal into chemicals like gasification, liquefaction, and pyrolysis. And next, gasification. In gasification, coal reacts with oxygen or steam at high temperatures to create syngas, which contains carbon monoxide and hydrogen, used to make things like methanol and ammonia. And then for the liquefaction turns coal into liquids, fuels, or petrochemicals. Direct liquefaction involves reacting coal with hydrogen, while indirect liquefaction first turns coal into syngas, then into liquids. For product diversity, coal processing can produce a wide range of products, from fuels to chemicals used in many industries, offering flexibility based on market demand. And for the environmental considerations, coal processing has benefits but also environmental challenges like greenhouse gas emissions and air pollutants. Cleaner technologies and carbon capture help address these issues. For the economic factors, the success of coal processing depends on coal and energy prices, market demand, and regulations alongside technological advancement and project scale. Next, for the full diagram, this diagram shows a schematic diagram showing how various chemicals are produced from coal gasification based on diagrams in TRAP 2001. Here is another diagram that shows gasification process for coal, depicting both the feedstock flexibility inherent in gasification as well as the wide range of products and usefulness of gasification technology. And another diagram that shows direct coal liquefaction, schematic from Shenhua plant in China from research of Dr. Caroline B. Clifford at the year of 2023. Continue, I will explain a bit of the simple breakdown of the full diagram and process, which is coal can be turned into useful chemicals through gasification or liquefaction. For coal gasification, coal reacts with oxygen and steam at high temperatures to make a gas mix called syngas, mainly hydrogen and carbon monoxide. Syngas can be used directly as fuel or refined into other products like synthetic natural gas (SNG) for heating or transport. For the coal liquefaction, the coal is heated and pressurized with hydrogen and catalysts to make liquid fuels of chemicals. Both processes aim to make coal more versatile by turning it into gases or liquids for fuels or chemicals. They need advanced engineering to work well and minimize harm to the environment.
Now, for the final products for this production of chemical from coal, which firstly, there is synthetic fuels. Coal can be converted into synthetic fuels such as gasoline, diesel, and jet fuel through processes like coal liquefaction and Fischer-Tropsch synthesis. Next, chemical intermediates. Firstly, there is methanol, which used in the production of formaldehyde, acetic acid, and as a fuel additive. Second, there is ammonia, which is essential for fertilizer production and as a precursor to various nitrogen-containing chemicals. Third, there is olefins or ethylene and propylene. This is a key building blocks for plastic, synthetic fibers, and other polymers. And lastly, there is aromatic hydrocarbon, which is benzene, toluene, and xylene. This is used in the manufacture of plastics, dyes, and pharmaceuticals. In conclusion, coal has a long history of being used to make materials and chemicals. It started the Industrial Revolution and has since been essential to many other sectors, including organic chemistry, steel manufacture, and energy generation. The transformation of coal into gas and liquid fuels and its use in the synthesis of syngas and ammonia had a profound effect on the development of technology and the world's economy. Coal has a rich historical past, but it also left behind health and environmental issues, including greenhouse gas emission and work-related injuries. Coal's importance as a source of minerals and chemicals decreased with the introduction of natural gas and petroleum. Modern coal-to-chemicals technologies such as coal liquefaction and coal-to-ethylene processes provide viable options in spite of these obstacles. This development makes it possible to directly convert coal into useful chemicals and fuels, expanding the uses of coal and fostering sustainability in the chemical and energy industries. Essentially, even though coal has been essential to the growth of industry, developments in coal to chemicals technologies are altering coal's position as a flexible and sustainable resources in the world economy.